We'll be looking at the quadratic time complexity. In the previous lessons, we looked at the constant time complexity and we also look at the linear time complexity. So here we're going to be looking at the quadratic time complexity and we're going to be showcasing some examples, and those examples will be on sorting algorithm. We're going to be using the insertion sort, the selection sort, and the bubble sort to demonstrate what quadratic time complexity means. Now, what is quadratic time complexity? From the PowerPoint side here, we know that quadratic time complexity, which is denoted as the order of, which is the big O n square, occurs when the execution time of an algorithm increases quadratically as the input size increases. So in simpler terms, if the input size doubles, the execution time increases approximately 4 times. So, or if the input size triples, the execution time increases by approximately 9 times. So let's just give a simple example before we look at the sorting algorithm. Now let's assume that we have a variable called n and we have a simple array. We have a simple list that contains an item collection of items. Let's use just three. Let's use 4, 3, and then 5. Now, this is a variable called n that holds this list, and this list has 3 items, right? So now this is how quadratic time complexity works, right? This is how we measure quadratic time complexity. So quadratic time complexity, normally we have the outer loop and the inner loop. The outer loop and the inner loop. So for the outer loop, let's use a variable called I. For I, let's start the I to 0 to the length of n. So this means that the I, we are looping this, right? We are looping this list. So we are starting a variable from the index 0, which, remember, this 4 is located in index 0, 3 is located in index 1, and 5 is located in index 2, right? So the I starts from index 0 down to the length of n. So the length of n here is the total number of n, the total number of items in the list, which is 1, 2, 3, which means that this outer loop will loop 3 times, which is like this, which is I equal 0. Remember, I starting at 0, I equal 1, and then I equal 2, right? That is how the outer loop works. So now we have an inner loop, which is for j, which is another variable. So we want the inner loop to start from in the 0 again down to the length of n. So which means this, what this does, right? What this explain, right? If the input size doubles, the execution time increases by approximately 4 times. So now here we have 3n input, which is 1, 2, 3, right? We have 3, so this will double 9 times. This will double 9 times. What it means is that when I is equal to 0, then the inner loop, which is a j, will be then j will be j equal to 0. Remember, j is starting from 0. So I'll copy this again. I just want to explain this. So when I equals 0 again, then j will be 1. Then when I equals 0, then j will be 2. Remember, we have a total items of 1, 2, 3, right? So j is looping 3 times for each I. So you can see, so it does the same thing for when I equal 1. It does the same thing from when I equal 1. So when I equal to 1, j equal to 0. When I equal to 1, j equal to 1. When I equal to 1, then j equal to 2. It still does the same thing again. So when I equal to 2, j equal to 0. When I equal to 2, j equal to 0. When I equal to 2, j equal to 2. Sorry, j equal to 0, 1, 2. So this is how it works, right? This is what we call the quadratic time complexity. So for each of the outer loop, the inner loop loops 3 times based on the instruction given to the computer. So this instruction here is telling the computer to loop on the outer loop, start from 0 and loop 3 times. On the inner loop, for each of the outer loop, also start from 0 and loop 3 times. So that means here we have an n input of 3, which is 3 times 2, which is 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the quadratic time complexity works, right? So now let's just go straight to a good example. Example 5. Let me go straight to example 5. Example 5. So example 5, we'll be using, we'll be looking at how the insertion sort works. Okay. Now, insertion sort is one of the sorting algorithm, right? So it works on the O(n) square, which is the quadratic time complexity. I'm going to see how it works. So given an array of this, so let me use this to demonstrate it, then we write the algorithm. So we don't want to use many items, right? So that we will not be slow here in this lecture. So if you can do for 3 items, you can do for any n items, right? So now let's assume this is the array, right? So here we have the 5, and here we have 0, and here we have 4, right? So now how insertion sort works is, by default, it assumes that the value located in index 0 is already sorted. The value located in the first index is already sorted. So what we're going to do, we're going to be comparing other index with the first index, and this is how it works. Now, it compares 0 with the first index 5. So if you are doing it in the ascending order, if you're doing it in the ascending order, then I would say that is this one less than this? But if we're doing it in the ascending order, then to be greater than. If you're doing it ascending order is less than. So let's lose ascending order. So if this is 0 less than 5, so since 0 is less than 5, so they swap position. So 0 comes here and 5 comes here, right? So it goes to the next line, right? So it's 4 less than 5. 4 is less than 5, right? So it's swap position. So 4 comes here and 5 comes here. It isn't done yet because it's comparing backward. You can see it's taken backward. So now it compares 4 and then 0, which is the first one. Is 4 less than 0? Now since 4 is not less than 0, so it assumes that this is sorted. That is how it does. That is how insertion sort works. So now let's write the algorithm of this simple stuff here. So let me cancel this. So how insertion sort works is, now we're giving a list, a variable called n that holds a list. So the list is let's say 5, 0, and 4, right? So once we write the algorithm on how the computer will perform that operation we just explained earlier. So now we say for I, right? So now remember that we have assumed that this one has been sorted, which is the first one, right? So that means we are comparing backward. Remember, we compare if this is less than this, and if this is less than this and less than this. So that's how the insertion sort works, right? So we're just inserting it down to the first. We assume that the first index has been sorted, right? So since we assume the first index has been sorted, right? So we won't start I. We'll start I from 1 down to the length, right? Down to the length of n. That means we are not comparing this one. So that means for I to the length of n, which means that when I normally it's supposed to be I equal to 0, I equal to 1, and I equal to 2, right? Because there are 3 items, so it's 2 iteration. But we're starting 1, so that means we are skipping I equal to 0, so it becomes what? I equal to 1 and equal to 2. Right, so that is what this one does. So now we need to have a key that we save the first, the I equal to 1 value, which is this one, right? So to now be to get a value which is n, which is the least, then the I, right? So it means that the key on the first iteration, so when I equal to 1, our key is equal to 0. So the key holds 0 in the first when I equal to 1, right? So we have a variable again called j. So j will be I minus 1, right? So j means will be I minus 1, which is when I equal to 1, our key is 0, then our j is equal to 1 minus 1, which gives us 0. It means that in the first one, when I is 1, our j is 0, right? So now what happens here? Then what happens here? Remember, we're writing the algorithm here, so this is not part of the algorithm. This is what's just for using to explain how this works, right? So we have an inner loop. The inner loop will be for the j. Remember, this is a j, right? We are using this j. Let me use small letter. So in the for j down to, or let me don't use 4, let me use the y. So now while I will explain this, yj is greater than equal to 0, right? Because if you check here, what we're trying to do here, we want to make sure that j is not less than 0, but j should be greater than or equal to 0. I will explain this one, right? So yj is not less than 0, right? Then and j is, and okay, before I go to the insertion sort, let me just explain something. Now if I say if and j is less than the length of the n, so how this works is this, right? How this works, this is not part of the algorithm, but I just want to explain this so that you can understand it. How this works is this. Now we are saying that yj is greater than equal to 0 and j is less than the length of n, right? So what happens? J equal to j minus equal to 1. So how this works is this. When I equal to 1, remember this first one here, when I equal to 1, the key is 0, right? So the j starts from 0, and we are telling the computer that yj is greater than equal to 0, which if you check here, it's this j is equal to 0, right? So this will stand, right? And j is less than n. We're telling the computer to loop j minus 1, which means loop j minus equal to 1. So it means that what we're trying to do is when I equal to this, right? So j equals to 0, this stands. So if you say j 0, which is 0 minus 1, which is minus 1, right? So there's no minus 1. So this stops at when I equal to 0 like this. So when I equal to 2, the key will now be equal to, the key will now be equal to 4, right? So our j will be equal to 2 minus 1, which is what? 1, right? Our j will be 2 minus 1, which is 1. Then it doesn't stop here because we're using a while loop here, right? So it means that when I again equal to 2, our key still remain at 4. Then our j becomes what? 1 minus 1 equal 0. Remember, because of this decrement, so the j is going backward, right? The first one is 2 minus 1, right? So this is minus 1 equal to, we're minusing for each of the j as it loops through, is reducing 1 from it. So 1 minus 1 is 0. So you can see this is how this loop operates. This is how it works. So when I equal to 1, key is 0, j is 0, so it stops here. So there's nothing like j minus 1, right? So when I equal to 2, the key is 4, which is this. Then j is equal to 2 minus 1, which is this. 2 minus 1, which is 1, right? So because we're saying that yj is greater than equal to 0 and j is less than n, so this operation will still performs until j gets to 0 and then stops for each of the I, right? For each of the I. So you can see what happens here, right? So it means that when I is still equal to 2, the key equal to 4, then j is equal to this 1 now, minus 1 equal to 0. So it stops here. It means that for when I equal to 2, we have 2 iterations here. Then when I equal to 1, we just have just 1 iteration. So that is what it means. That is what the code means. So now let's move straight to the insertion sort, right? So why j is greater than or equal to 0 and j, so here will be, we want to get the value of this j, right? So it will be nj. So this nj now, remember the nj is this is I, right? I started from 1, which is 1 minus 1, which is 0, which means that this j automatically is in index 0, which is 5, right? So n of j is picking the value 5, right? So if the value 5 is great is greater than the key. So remember that the value in the key here is what, 0. It means that in the first iteration here, right? In the first iteration here, if 5, right, is greater than the key, what happens? What do we tell the computer to do? We want the computer to swap the position. So we want the computer to say the n j plus 1 n j plus 1 and equal to n j. Can you see that, right? So let me explain this one, right? So if you check when I equal to 1, right, and the key is 0, remember when I equal to 1, when I started on 1, so the key is 0, then the j, which is this j, I minus 1, which is 1 minus 1, which is 0, right? Now, why j is greater or equal to 0, which the rule stands. This rule stands because j is greater j by the in the first iteration is equal to 0, which is this one, right? And n of j, so what is n of j? So n j, n square bracket j is equal to 5, right? It's 5. Can you see that it's 5 because j, so n of j, which is n0, is 5. So if 5 is greater than the key, so the key here is 0. So what happens? So this rule stands because this rule stands. Why j is greater than or equal to 0 and nj is greater than the key. So this rule stands. So that means we are swapping then nj plus 1. So the nj plus 1, then nj plus 1 at the first iteration. Remember j is 0, which is 0 plus 1, right? We give you 1. So it will be n1. That means that n1 now, which means that in this loop here, right? So nj plus 1 will give us what? Remember nj is 5, right? So we want to replace this nj plus 1 to 5. So it will not be, so in this loop will now change to 5, 5, and then 4. That's what it means, right? 5, 5, and 4. Because the nj, the value that nj holds is 5, right? Right? And then if you are replacing this nj, if you are passing the value in this nj to nj plus 1, right? So nj plus 1 was supposed to be 0, right? Nj plus 1 is supposed to be 0, but we're replacing it, so the answer for this first iteration will be 554, which should be, so nj plus 1 supposed to be, so nj plus 1 here supposed to be 0, but because we're replacing it with the nj value, so it becomes, so the list becomes 554, right? So that is what it does here. But right, so now 554, so this is decrementing, the j is decrementing, which is j minus equal to 1, and the initial stage here, right, the j is what? 0. Remember the j is 0. So if the j is decrements here, so the j becomes what? Minus 1. The j becomes what? Minus 1. So for all the computer not to malfunction, so what you will do as a developer, so you go outside the while loop. Remember, this is the for loop, right? So outside the while loop, okay, sorry. Outside the while loop now, you now say nj plus 1, nj plus 1 will now give you what? The key. Now let me explain this. We have already understood this, right? Remember the nj, this is the answer for the first loop, which is 554 within this loop here. But where is our zero? That means if we stop the loop here, the computer will lost this zero. This zero will be lost, right? But the end goal of this algorithm is, right, we want to sort this algorithm, right? So this zero will be lost. So what we need to do here is the computer needs to keep this zero, and if you check in the initial place here, the key is already holding this zero, right? So here we have 554. And then in the next loop, we are telling the computer is j minus equal to 1, which is j is 0, which is 0 minus 1. Automatically, it's like j will now becomes minus 1. So here in the next line, when you say j plus 1, it becomes minus 1 plus 1, which means n equal to n 0 equal to key. So we'll now assign that 0 down to n0, which becomes, so in this first iteration here, then the 0 comes into this place. So it becomes what? 054, because the key is already holding 0. And then this nj plus 1 becomes n minus 1 plus 1, right? Minus 1 plus 1 becomes what? Index 0. That's why we're storing it in the first place. Now, do you get it? Now, in the second iteration, when I equal 2, in the second iteration when I equal 2, so our key here, so this is the new list now. The computer is no longer using this one. So our key here when I equal 2, which is 0, 1, 2. So our new key here becomes 4, which is correct. Is our new key. Our new key becomes 4. Then our j is equal to 2 minus 1, which is 1. So our j now, this is our j, which is 2 minus 1 equals to 1. So our j now becomes what? So our n of j here will become what? 5. Can you see that? Our n of j becomes what? This 5. Alright? So that is what it means. Our n of j becomes this 5. So it means that the n of j, so if j is greater than 0 stands, and n of j now is if is greater than so what is our key? Our key is 4, right? If it's greater than our key now is 4. If it's greater than 4, so it means that, so the list will now be, the new list now will now be, will swap, right? So nj plus 1, right? So nj plus 1 will now be, remember the j here, remember the j here was 1, right? So nj plus 1 will now be 2. So our list will now be 0, 5, and then 5, right? 0, 5, 5. So coming in here, we have j is incrementing, is decrementing, right? Our j is incrementing, which our j was 1, right? 2 minus 1, 1. So if our j decrements here, right? So it becomes what? 1 minus 1. If our j decrements here, it decrements by 1, which is this one here. It falls to this place. It falls to this place here, right? It falls to this place, which is 1, right? So now, coming to this place here, coming to this place, we now have 1, because our j was 1, right? So if it decrements, it becomes what? 0 in this instance. Decrement, it becomes 0. So it will now be 0 plus 1, right? So 0 plus 1 becomes what? We want to pass the key to n of 0 plus 1, which the key here was 4, right? So we are passing the key now to the, we are passing the key value to the index 1. So which this loop now becomes what? So the key value was 4 here, right? The key value was 4. So it becomes what? 0, 4, and then 5. That's what happens here. Now in the third iteration, yeah. So within this while loop, in the third iteration here, when I equal to 2, k, the key still remains and j is this, right? j is 1 minus 1, which is 0. But look at it here. We already assume, you can see that the thing has already been sorted in this when I equal to 2, right? You can sort it here, but because of this instruction, the computer must perform this, right? The computer must perform this. So here the keys to remain 4, because we are within here. The keys to remain 4 and j is 0 already, right? So j is 0. So n of j. So n of j here. So n of j here will now be mm, will now be 5, which is 0. So n of j here will now be 5. So we are looking at this new one now. This new one. So n of j will now be 0. So looking at this now, we already know that this has been sorted, which is 0, 4, 5, right? This has been sorted. So when I equal to 2 and j equals to 1 minus 1, then 0 and this. So this has already been sorted. So the iteration will return at the end of this iteration here, it will return the sorted list, which is 0, 4, 5. Now, this is how the insertion sort works. So there's not enough time. In the next video, we're going to look at bubble sort and then the insertion, the selection sort, right? So this is the algorithm for the insertion sort, right? So for I equal to the length of n, so key, this is a key. So this, we have explained this, we'll explain this, and we'll also have explained this. So these are it works. So thank you and God bless you. In the next video, we're going to be looking at bubble sort, and also we're going to be looking at the selection, the selection sort.